Let us look at this question. A particle of mass 100 grams, so mass is given 100 grams, 0.1 kg, is thrown vertically upwards with a speed 5 meter per second. Suppose there is an object here, it is thrown upwards with a speed of 5 meter per second. The work done by the force of gravity during the time of the particle goes up. Suppose it reached this point, this is the maximum point. So while it is moving up, the gravitational force will be acting in the downward direction. Displacement is in the upward direction. So we can clearly say that the work done is negative, because work done by the gravity here they are asking. So we can clearly eliminate these two options. Obviously, because it is projected upwards, displacement is along the upward direction. The work by the gravity, the force is along the downward direction. So definitely it is going to be either A or B. Okay, now, so by applying the conservation of mechanical energy at this point A, which energy will be there? Only kinetic energy will be there, because we will consider that potential energy U is equal to 0 here at this point, height equal to 0. Let us suppose this is the height h. At this point, maximum height, velocity equal to 0. So here we don't have the kinetic energy. We will have only the potential energy. Okay, let us now suppose this is the point B. So now we can apply the conservation of mechanical energy. Energy at A is equal to energy at B. At point A, only kinetic energy is there. That is half mv square. That is equal to. At point B, only potential energy is there. That is due to the height, because velocity is 0 at that maximum height. So that is m into g into h. So we should not find out, we should find out the work done, right? So this is the work done. This is the work done. But if we are asked to find out the work done by the gravity, we will put minus symbol here. Work done by the applied force is mgh. Work done by the gravity is minus mgh. Clear? Right. Now let us see that. No need to cancel. Directly put the values, half mv square. You will get half into mass is 0.1 kg. We can write 1 by 10 kg into v square. What is v square? 5 square. That is 5 square into 1 into 1, 25 by 2 into 10 is 20. That is the work done due to the gravity. Minus, so send work done, put the minus here. This is 4, this is 5, minus 5 by 4. That is the work done due to the gravity. This is minus 1.25 joules. So option B is the right answer. Clear? Right. Let us see the next question. A 2 kg block slides on a horizontal floor with a speed of 4 meter per second. Okay, there is a horizontal floor, and that there is a 2 kg block. It is moving with 4 meter per second. It strikes an uncompressed spring. So there is a spring here. It strikes an uncompressed spring and compresses it until the block is motionless. Means, so finally what happens? The block will move here and finally it will reach here. In this situation, the spring will be tight, compressed like this here. The kinetic force, the kinetic friction force is 15 newtons. What is that kinetic frictional force? 15 newtons. Okay, so, and spring constant is 10,000 newtons. The spring compresses by. Okay, now let us apply the work energy theorem here. The work work done by the block. See here, let us consider the block is exactly right beside this. See, this is the natural length of the spring when it is not compressed. Here it is having the 4 meter per second. That is the meaning of that. Okay. So let us take the initial position of the block here, right beside the spring. In this point, at this point it is moving with 4 meter per second, right? So when this compression is made, starting from here, let us suppose X is a compression. Okay, X is the compression done on the spring, or the block has slided for X meters or X centimeters. Right, now in this case we can clearly say that the work done by the block, friction, see, when the work done on the spring plus work done by the external force is equal to plus work done by the friction also we have to consider here is equal to change in the kinetic energy. Okay, here kinetic energy we can take it as half mv square. Okay, the block will be at rest finally. Okay, the block will be at rest. Finally it will be at rest. So kinetic energy will be half mv square. Now work done by the spring, work done on the spring, or we can say half kx square, right? Plus there is no external force. Let us remove this. Only we have the frictional force. Frictional force into displacement is x. Suppose this block is moved for x distance, the friction also will be acting for that x distance. So F into x. Okay, let us substitute the values each. Half into k value is 10,000 into x square plus what is that? F. Frictional force is 15 newtons into x is equal to half into mass is 2 kg block into velocity is 4 square. So 2 cancel here. So here this 2 cancel this 5,000 times. So 5,000 into x square plus 15 into x is 15x. By sending this other side, minus 60, 4 square is 16, sending minus 16 here, plus 16 here, it will become minus 16. So this is the equation we got. So by calculating this, this is a quadratic equation, we know that minus, see, this is A, this is B, and this is C. C is minus 16, B is 15, A is 5,000. So we know that x is equal to minus b plus or minus root b square minus 4ac by 2a. This is the root for this equation. We cannot directly factorize this one. Okay, it is not so easy to find. So let us find out the minus 15 plus root of. See, here we are not going to find out the minus because it is towards the right. Let us take only plus. No need to take the minus condition here. B square 15 square 225 minus 4 into a into 4 into a is 5,000 into c 60 minus 16 minus into minus plus by 2 into 5,000. Understood? So 4 into 5, 4 into 16, 64, 32,000. Okay, So 4 into 5, 20,000, 20 into 16, 32,000. Okay, so plus 625. So finally, if you solve this, you will get the answer B, 5.5 centimeters. Okay, calculate that, you will get this answer 5.5 centimeters. Clear? Right, that is the X value, that is the spring compression made on the spring. Okay.